So in this video, we're going to go through an example of going from a 3-variable problem down to a 2-variable problem. So let's read this through. Each day, a factory makes 3 types of widget. Now, just so you're clear on this, a widget just means a product that the company makes. And there are 3 types. There's basic, standard, and luxury. The widgets produced need 3 different components, type A, type B, and type C. Basic widgets need 10 components of type A, 9 components of type B, and 5 components of type C. Standard need 8 of A, 12 of B, and 10 of C. Luxury needs 4 of A, 3 of B, and 25 of C. Each day there are 300 components of type A available, 300 of type B, and 600 of type C. Each day the factory must use at least twice as many components of type C as type B. Each day the factory makes X basic widgets, Y standard widgets, and Z luxury widgets. So that deals with defining the variables. It's already done for me. Okay, so part A, in addition to X is greater than or equal to 0, Y is greater than or equal to 0, and Z is greater than or equal to 0. So that's the non-negativity constraints dealt with as well. I don't need to worry about those. Find 4 inequalities in X, Y, and Z. The model the above constraints, simplifying each inequality. Now, what's useful in the way that sometimes these questions are laid out is that they already look like they're laid out in a table. So if we're focusing on components of type A, then you can see we've got 10, 8, 4, 300 already set up. We've got the 9, 12, 3, and 300 for type B, and we've got 5, 10, 25, and 600 for type C. So we can set up an inequality for components of type A, because if X is the number of basic widgets and I need 10 components for each basic widget, then that is 10 lots of however many basic widgets there are. So the number of components times the number of widgets, plus 8 components for each standard widget, and 4 components for each luxury widget. Okay, and there are 300 components of type A available, so that can't go above 300, so it's less than or equal to 300. And we want to simplify that inequality down, so I'm going to divide through by 2. So we're going to get 5x plus 4y plus 2z is less than or equal to 150. So that's my first inequality. Now we're going to set up an inequality for B. So here we're going to have 9 lots of x, so looking down that column, plus 12 lots of y, plus 3 lots of z, and there are 300 available, so less than or equal to 300. And then I want to divide through my inequality by 3. So 3x plus 4y plus z is less than or equal to 100. Now I'm going to look for an inequality for C. So again, look down the column, 5x plus 10y plus 25z is less than or equal to 600. Now I can divide that through by 5. So x plus 2y plus 5z is less than or equal to, so 600 divided by 5 is 120. So now I have 3 of the 4 inequalities that I need. The final inequality is going to come from this line here. Now it's one of those nasty ones. Each day the factory must use at least twice as many components of type C as type B. Okay? So in doing this, what I need is to think, right, the number of components I need for type C, well, for type C, I've got 5 components in each basic widget, 10 in each standard, 25 in each luxury. So actually, this is describing the total number of components I need for type C. So I need 5x plus 10y plus 25z to be at least, so greater than or equal to, twice as many of components as type B. Now, type B is given to me by this. This is the total number of components I need for type B. So 9x plus 12y plus 3z. So now what I want to do is simplify this inequality. So I'm going to multiply it out. So 5x plus 10y plus 25z is greater than or equal to 18x plus 24y plus 6z. Right, now what I'm going to do is I'm going to take 6z from both sides, and I'm going to take 5x from both sides, and I'm going to take 10y from both sides. So I'll leave me with 14y. Okay, so now I have 4 inequalities as simplified as I can get them. Okay, right, let's move on to this next bit. On a particular day, the factory must make the same number of luxury widgets as basic widgets. Now, what does that mean? Well, the number of luxury widgets is given by Z. And if that's the same number as basic widgets, well, basic widgets is given by X. So that means I'm going to replace all of the Z's in my inequalities with X. Now, that reduces the 3-variable problem down to the 2-variable problem, which is precisely what we wanted to show. So I go to my first inequality, and I'm going to replace the z with x. So I'm going to get 5x plus 4y plus 2x now is less than or equal to 150. So 7x plus 4y is less than or equal to 150, which is precisely that first inequality. Excellent, done. So now I go to my second inequality, and I'm going to replace the z with x. So 3x plus 4y plus x is less than or equal to 100. So I've got 4x plus 4y is less than or equal to 100. Divide through by 4, and we get the x plus y is less than or equal to 25, which is the second inequality. Right, looking good so far. Right, I go to my third inequality, and I replace the z with x. X plus 2y plus 5x is less than or equal to 120. So I've now got 6x plus 2y is less than or equal to 120. Divide through by 2, and I get the 3x plus y is less than or equal to 60, which is the third inequality. Right, so the last one, I get the z and replace it with x. So 19x is greater than or equal to 13x plus 14y. Take 13x from both sides. So 6x is greater than or equal to 14y. And then divide both sides by 2. So we're going to get 3x is greater than or equal to 7y, which is precisely the fourth inequality. So we've reduced the problem down now. Okay, so now with those inequalities, I'm now going to draw a suitable diagram to enable the problem to be solved graphically, indicating the feasible region. So I now need to draw these 4 inequalities. Now don't forget, we have the x is greater than or equal to 0, y is greater than or equal to 0, z is greater than or equal to 0. So I can immediately shade in x is greater than or equal to 0 and y is greater than or equal to 0. Okay, so the non-negativity. Right, well, let's go for this 7x plus 4y is less than or equal to 150 first. We're going to try and draw that on. Okay, so let's think. What could I use? Well, sometimes these can be quite difficult to draw, as you well know. So I know that when x is 0, I'm going to get 4y is 150. So y is going to be, well, 150 divided by 4, which is 37.5. Okay, which is off the scale. Okay, so I can't use that. So how about x is 10? Let's try that out for size. So that would mean I would have 70 plus 4y is equal to 150. So 150, take away 70, then divided by 4 gets me 20. So 10, 20 is a point that is on my grid. Okay, so that's on the line. Right, I found one. Now let's try x is 20, shall we? So we've got 140 plus 4y is equal to 150. So that would mean y is 2.5. Now, 2.5, so I can pretty much draw that. That'll be about there. So I'm going to run with that. Okay, that'll do. Right, now, which region should I shade? Well, if I try 0, 0, 0 plus 0 is less than or equal to 150, so that satisfies it. So 0, 0 is in the feasible region at the moment. So I'll shade the bit I don't want. Like that. Okay, so we've got our first one. All right, give myself a bit of space. Right, so the second one should be a little bit more straightforward to draw, I would hope. So x plus y is less than or equal to 25. I still can't go x is 0, y is 0, but I can go x is 5, y will be 20. So I know that it's going to go through that point there. So x is 5, y is 20. And when x is 20, y will be 5. So it's going to go through that point. So that's quite straightforward. Oh, didn't draw that very well, did I? Let's draw that one more time. Okay, I'll do. Right, and which region is it? Well, 0 plus 0 is less than or equal to 25, so that's in the feasible region. So I'll show the region I don't want. Okay. Right, next, the 3x plus y is less than or equal to 60. Well, when y is 0, x is going to be 20, so it's definitely going through that point. So that's good. Right, I need one more point. So what if x is 15? So we're going to get 3 lots of 15, so 45 plus y is 60. So that means y is 15. So 15 is a point. Okay, so we can draw our line going through those 2 points. Okay, and show the region I don't want, and it's to the right of it again, because 0, 0 will be inside that feasible region. Okay. Right, and last but not least, we've got 3x is greater than or equal to 7y. Now I know that it's going to go through the origin. So I just need one more point. So I know that when... So let's just get rid of this, just to avoid confusion. I know that when x is 7, I'm going to get 21 on the left-hand side, so y would be equal to 3. So 7, 3 is a point that's on the line. So actually, I could go and double that, couldn't I? And go to x is... go another 7 along to 14, and then up to 6. So 14, 6. Draw a line. Okay, now we've got to shade the region I don't want. So which region is it? Well, if I try, let's say try 5, 0. Well, x is 5, so we get 15. Is that greater than or equal to 7 lots of 0? Yes. So 5, 0 is in the region, so I shade the region I don't want, which is above. So it actually turns out, it looks like we've got a redundant line, and that was this one here, that x plus y is equal to 25, or less than equal to 25. So that one, because it's not cutting up part of the feasible region. So this is your feasible region. Okay. Right. So the last bit of this question is find the total number of widgets made on that day. Okay, so the total number of widgets, let's call it n, is going to be equal to x plus y plus z. That's your total number of widgets. But remember, z was equal to x. So actually, this is x plus y plus x. So our objective to maximize is the 2x plus y. Okay, now, looking at points that are in your feasible region, one possible contender is this one here. And it looks like that one there, that's close to the corner, because we're doing some integer linear programming here. So they're probably the two I'm going to try, but I should probably also try that one there. Okay, the 20, 0. So which one of these gives me the maximum? Okay, so let's see. So x, y, n. So let's try 20, 0 first. So we've got 2 lots of 20 plus 0, so 40. Right, let's try the next one to the left. So that is 18, 6. So we've got 2 lots of 18 plus 6 is 42. So that's a little bit better. Let's try the next one to the left, which is 17 and 7. So 2 lots of 17 plus 7 is 41. So 42 is giving us our maximum. So it is 42 widgets. And that's coming from 18 was x. So x is equal to 18. y is equal to 6, and z, remember, was the same as x, so 18. 18 plus the 6 plus the 18 gives you the total of 42.